And we are going.
Excellent. Good morning.
Good morning.
Stay near the mic. Is that good?
Yeah.
All right. Good morning. Welcome to BSides. Yay! All right. Oh, that's a good way to get the morning going. My name is Josh Schuster. I'm one of the organizers here at BSides Boston. Obviously, thank you all for coming. This is what makes it such a great event, is everyone who comes and attends, and a great turnout here at 9 a.m. on a fine Saturday morning. Remember, BSides is an event. It's what you make of it. So some of you have been here before. I see a lot of faces that I know, and some I'm sure are new. So take this advantage to meet with other people, obviously meet with the folks that are out there, and learn and check out different things. We've got a Lockpick Village. We've got a CTF running downstairs, Capture the Flag, if you haven't seen that. Pretty interesting event. What else do we got going on? There's a couple of big things, and like I say, out here we've got a number of vendors. If you have any questions, staff members have a red lanyard, so we don't have specific shirts, but if you see anybody with a red lanyard, just ask a question. We can get you to the right person. There's somebody posted out front here on the 4th floor, and then again, it's the 4th and the 2nd floor. This is probably one of the key things, because after a while you might forget, and like, I'm going to go to the other floor. Don't go to the 1st floor. Go to the 2nd floor, otherwise you might get stuck in an elevator there. So I think that's all I had for an introduction, and so we'll get going here. Keynote is at 11, so be ready for that. So at first I want to introduce Robert. Robert's an independent software and security consultant, developer, speaker, obviously, and trainer. He specializes in developing custom software business solutions for a lot of industries, and provides secure code reviews and other software security assistance to companies. He's spoken at national, international conferences and various security topics. So threat modeling is going to be a great topic. Robert, take it away. Thanks.
Well, good morning, and thank you as well for coming out this morning on a beautiful Saturday. A little cool, but it's a nice day for sure. So today we're going to talk about, as we mentioned, threat modeling. And the reason why I titled this is threat modeling for me. I already know it's for me. I use it quite a bit, and it's very helpful for my own practice of security and helping companies. So it's really you to ask the question, is threat modeling for me? Is this something that I want to look at if I'm not doing it already? Is it something I need to maybe revisit again? Maybe I tried it once and it didn't work, or at least I didn't think it did. And I need to think about it again. So hopefully this is a way to kind of bring that to your attention. I don't know why that's flickering, but hopefully it doesn't do that too much. A little bit about me. You just gave me an introduction. We'll move on from that. Threat modeling helps you do what? Now, before I get into this, let me just mention, I talked to several people in the security industry and say, hey, do you do threat modeling? Do you know threat modeling? And I get many, many different answers about what threat modeling is. There are several that will look at more operations-based threat modeling, attacker threat modeling, network threat modeling. What I focus on mostly in my own work is software-based application-level threat modeling. In other words, applications that are built, and then what are the potential threats? What are the potential issues and problems that you might have with those applications, and how to make sure they're secure? So for me, threat modeling, I believe, helps you, first of all, identify threats that your system may face. It also challenges your assumptions. I don't know how many times that I've worked with a customer, and they may have a development team, and I ask them, okay, do you know it's secure? Do you know it deals with these certain issues? Oh, of course, yeah, we already know. We already deal with that. But what I find with threat modeling, once you start doing the exercise and start looking a little bit closer at what is there, challenging some of those assumptions comes up very, very quickly. And they may realize, oh, wait a minute, we didn't do as much as we thought. Or it worked great in development, but or we thought it would, and we changed a few things, and now it's not working quite the way we thought in production. So it challenges assumptions. It also, and I think this is a key thing, and some people miss, is that it prioritizes other things that you're doing for security. For example, many people know about pen testing. It's a great tool. A lot of people use it. I've used it. It's great. Reviews, I use those as well. It's a great tool. And fuzz testing and all of those are great tools. But what threat modeling can give you on the forefront is, how do I know to best use those tools? Where do I use them? What makes sense? For example, I've seen a customer engage with a consulting company to come in and do pen testing. And they did all kinds of SQL injection tests and all kinds of other things. And they said, you know what? You are absolutely secure against SQL injection. We could not find a single problem. That's great, because we don't even have a database. What are you talking about? Well, you know what? A threat model would have told them pretty quickly they didn't have a database, so there was no reason to actually do that kind of pen testing. They could have changed it and been more focused on what they were doing. So I think that's one of the other benefits of threat modeling. It helps you narrow in on the things that you can do with the other tools that you may have in your tool belt. And then also documenting what you have learned as you went through the process. So just some quick definitions. I'm not going to spend a lot of time in this, but a couple of things to point out. I don't know why it keeps flickering. Sorry. A threat is essentially the adversary's goal. Now, we may think of, like, for example, a web application. Well, I have an XSS issue. I have CSRF issue, and so forth. Those are not actually the threats. It's actually, the threat is what we're talking about is the goal. For example, as we'll see a little bit later, one of the things that comes out of Stride is spoofing, being able to spoof a request, or elevation of privilege, being able to be at a higher level of privilege than I normally am able to be. That's a goal, and that's actually a threat. That's not related to these other things. Those other things actually are related more to the vulnerability. So it's a flaw in a system that could help a threat or an agent be able to realize that threat. Okay? So that's the difference. Just subtle, but a threat is the goal. I want to be able to get credit card information through some kind of information disclosure. That's my goal. And the threat is I have information that's being disclosed in some way, passwords that are open text or other kinds of things, or credit cards that are open in the database and so forth. Assets are things of value. We're trying to protect. Attack is, obviously actually doing the work of trying to get the things that we're looking for, the goals we're looking for. All right? So, when you're starting to do threat modeling, and this may be in your own company, this may be for a customer, this may be for your own application, one of the things you want to do first is gather documentation, gather information about what it is that you're going to be working on. Get a good idea of the environment. Get a good idea of the application, requirements, design, so on. Gather your team. Now, here's something I think that some people miss in terms of threat modeling is oftentimes threat modeling in the past has been assigned to one person, and sometimes is assigned to a junior person, or it may be assigned to the architect, or it may be assigned to a business person, perhaps, who has no idea about the application at all in terms of the internal workings. I believe that to do threat modeling properly, you need to have a team. You need to work with several people who have different understandings about the system. First and foremost, and again, I'm coming from a software perspective, you want developers. Developers know the code better than anybody else. And so when you're mapping some of this out and what's going on with the system, you want to have developers there. And of course, architects, project managers, business stakeholders, other people that have some idea about what the application is about and maybe some of the goals and so forth are all useful in threat modeling. Okay? Now, you may not be able to have everybody, but have some key people from each of these, I think, is really, really key to be able to do good threat modeling. You want to understand the business goals. What exactly are we trying to do? What is our objective here? Sometimes business goals and security don't always match. As a security person, I may come in and say, I want you to be locked down. I want you to, and the business may say, well, we only want that for certain people, like administrators. But for everybody else, we want to have, a little bit freer reign. Okay, well, that's a business goal versus perhaps a security goal. It's good to know those things up front. technical goals. What do they want to do here, and what have they chosen for their framework, and what have they chosen for languages and platforms and so forth. Those are good things to know. Agree on a meeting time and date, and then plan on 1 to 2 hours at a time spread out over a week or a few weeks. You don't want to do this too much. You don't want to have a whole day of this, and the reason for that is, quite frankly, it becomes a little tiring. I mean, this is intense work, and the other thing you want to do is keep sessions focused. If you just have hours of this thing, it can turn into a review session. And it's not a review session. What you're doing here is you're focusing on finding problems and then determining how can we address those problems, and then ultimately circling the loop and making sure that those problems are either handled, taken care of, or passed away somewhere else, or just left alone. So you want to be able to spend good time focused, so be sure not to spend a long period of time on these. Okay, this comes from an excellent book, and I want to highly recommend this to you, Threat Modeling, Designing for Security by Adam Shostak. And in his book, it came out last year, 2014, or actually about around this time a year ago, and he gave a framework of 4 questions. The first one is, what are you building? What is it that you're trying to build? Now, threat modeling ideally happens before you begin work, not after. Now, the real world, a lot of us look at this, oh, we already built the application. Now, what are our problems? Ideally, you want to do this before. But either way, the first question is, we need to understand, what are we building? Secondly, what can go wrong? What is the possibility here? I've got a banking system, and I've got one-way password, no two-factor authentication of any kind, or things like that. What could go wrong here? And then the third question is, what are you going to do about it? Now that you know what you're building and what could possibly go wrong, what are you going to do about it? All right. The fourth question is, now that you've answered all these, did you do a decent job of the first 3? Are we making sure that we understand exactly what we're building, we understand all the potential issues, and then also have a pretty good idea of what we're going to do about it? And if we don't, let's go back and do one of those again. And that's essentially it. 4 questions. And those 4 questions really break out into steps. Model the system. So how do we know what we're building? We model the system. How do we know what's going to go wrong? Well, we identify the threats. We understand exactly the kinds of things that could potentially occur. And then what are we going to do about it? Well, address those threats. Risk analysis and so forth. And then validate your work. Verify that you did what your objective was. Okay, so starting off with modeling the system, one of the ways that has been out there for a number of years is using a data flow diagram. Essentially, taking your application, your system, or whatever you're trying to understand, and model it in a way of what are the entities, what are the processes, and where's the data store, and how does the data flow? Because typically, where the threats happen most is when data is either at rest or in transit. We're getting data, we're sending data. Those are the places that typically are most vulnerable. And of course, also at rest, where we put the data can be vulnerable. So this is a good way to start modeling the system and thinking about it. And there are other ways that you can do this as well. This is just one in particular. But the idea is to get a high-level view. It's not where I'm using some kind of class diagram or something like that. We're not talking that low. We're talking a little bit higher to just see how things work together. So just to give you a quick, oh, and I missed the privilege. Everything crosses a privilege boundary. So to kind of give you an idea, if I have users, and a user could be not just users, but maybe a browser on a system. But let's say with users, hitting a server, an admin user, hitting the server as well. request response, settings. Maybe the admin has some settings and logging data or verifying logging data against that server. And then you have privilege boundaries where you're crossing. So here I'm untrusted, but now I'm in a secure environment. And the same thing with the admin going back. This one's a little bit bigger, more involved one, but you can see here user with a service, data files, audit files, authentication engine, credentials, and so on. All the different interactions, just at a high level. You don't need to go into a lot of details here, but just at a high level, what are the moving parts to my system? I may have a service out here. I may have an old mainframe database for whatever reason that's still running and I'm still using it. What are my things that I'm using out here? And then identify those. What are the data flows? What is going back and forth? And then ultimately, what are the privilege boundaries, the boundaries that we cross with trust from an untrusted to a more trusted section of the application. So once I have that, once I know what essentially my application looks like, and I've kind of identified the high level, and in some cases you may have so much, you may have to drill in a little further. So you may have a high level, then you might go down to one section and go a little further and diagram that, and that's fine. But once you have some of these diagrams and have a good idea, next thing is to identify your threats. And there are many, many ways to do this. One way is to use attack trees. Attack trees are great for just giving you, okay, if I have this kind of system, and there are certain steps that an attacker would use to get through the system, verify that against my system to see where I am for an attack tree. Attack trees are actually kind of hard to make, so you don't usually make them. It's more that they've already been done, and then you just see what actually matches your system. One drawback is that it may not be an exact match, but they are a good tool. Threat libraries, CAPEC, OWASP Top 10, and actually for OWASP, I actually like the application verification project a little bit better than Top 10, only because it's a little bit more involved and actually has lists. And lists are not bad because being able to see, okay, where are the problems, where are we in relation to that? Not a bad way to go. Checklists, as I mentioned, use cases. One way, and this came out of Microsoft about 10 years ago and has a lot of information out there, and in particular, Adam Shostak's book is on this mostly, is Stride, which we'll talk about in a moment. There's a new one that's out there right now, and I don't know if anybody is familiar with this or have heard of it. I've heard of it in the last year, and there's a book that's coming out next month, and I'm interested in seeing what they have to write. But I read a few of their articles. But this process for attack simulation and threat analysis, which basically combines some of these trees, business process, and coming up with a way of doing threat modeling. So that's another way to also find threats. But in particular, I want to look at Stride for the moment, because this is what most people hear about with threat modeling. So your threats are, for Stride, spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. Spoofing is doing something that I shouldn't be doing and pretending to be someone else. Tampering is obviously changing data or changing it in some way that shouldn't be that I shouldn't be able to. Repudiation is basically if you say I purchased this item and I say no I didn't, that's repudiation. How can I prove, or how can you prove that I actually made the purchase? Information disclosure, of course, is if I have data, a password, or any other kinds of information that shouldn't be out there, somehow it got disclosed. Denial of service, I think we know pretty well, is where basically you can't run anymore. Most dangerous one is elevation of privilege. That's the strongest one, the toughest one that you want to try to deal with, because essentially, if I'm a regular user and I can have admin rights, game over, right? If a user is able to get in, because typically admin rights, how do you protect against that? Well, not easily. Admin rights should, by default, be allowed to do most everything, right? And so that's the one that's the most difficult and important. And on the other side, I mean, what we're talking about here with these threats are that here are the threats, here are the ways we want to deal with them. These are the things that fix these things or remedy these things. So authentication, integrity, non-repudiation, basically saying, yes, I can prove that you did something. That's usually through logging. Confidentiality, availability, authorization. Now, this is a list. It doesn't cover everything out there in the world. There's no configuration management. There's no operations. It's mainly the big few items, certainly in software itself, not necessarily network and so forth. So some people say, well, I don't like Stripe because it doesn't cover everything. Well, its intent is not to cover everything. It's mainly for software. And so just be aware of that. But if you can see the key words, CIA, confidentiality, integrity, and availability, and of course authentication, authorization, and then non-repudiation, verifying, yes, you did do what I see in the system you did. It's catching a lot of things. So just be aware that when you hear, well, I don't like it because it didn't do everything. Well, it's not made to. It's very specific. So be aware of that. Okay, just briefly talk about threat trees. Essentially they are a graphical representation, generally based on hardware and certain patterns. Here's an example. Obtaining an authentication, just lost it, authentication credentials over the network. Clear text sent, attacker uses the tools, and attacker recognizes credential data. So that's a particular kind of threat, but here's the way that an attacker may use. If you have a threat, here's how an attacker may be able to obtain that data. So you would compare this against your system and verify, okay, if attacker did this, are we safe? Are we protected? So that's essentially how you're using those. You can also see it as just a verbal description. So what's the goal? Gain access. And here are the things that I may have in my system or may not. For example, if I can identify the IP address, what can I do? If I can get access control, what can I do? And so on. So another way to identify threats. Now there are a few tools. I think the simplest and easiest one is just a whiteboard. If you're in your group meeting with your team, get on a whiteboard and just say, here's what it is. Here's our model. What are the places that we might have problems? Okay. Another thing is to use Visio or an equivalent, some kind of tool that lets you diagram and keep track of that way. You can do Word. You can just verbally. You don't necessarily have to have the diagram. The diagram is, I think, helpful, but you can write everything down and certainly keep track of all your threats that you find. Another tool that's out there, a free tool, Microsoft Threat Modeling tool that came out last year, and I think it's like the 4th or maybe 5th version of this tool. Previous tools relied on Visio being installed. The latest one does not, and it's actually, I'm not going to be showing it today, but it's a nice tool. If you have a chance, take a look at it. There are a few little videos out there about it, and I'm going to be putting together my own training course on this very soon. But one of the things I like, or several things I like about this, is that you build out your model, and then it will give you hints to say, okay, because your building looks like a web application, here are some of the things related to the stride that I see that you potentially have problems within your application. So then you get some feedback, and then you're looking at various parts of your system, and then it'll say, okay, here's the suggested mitigation. And then you can track that, and you can also file bugs with it and keep track of it and store just an XML file stored in source control. So it's a nice tool. Some people like it. Some people, it's really Microsoft focused and Windows focused. Yes and no. It has some customization, so you can also add your own threats, and you can also add your own systems if you want to, with a little bit of work. Okay. There's also a nice game, which we'll look at briefly here, the Elevation of Privilege game by Adam Shostak. There's a couple other tools, Trike and Threat Modeler. Trike is a spreadsheet that you can kind of keep track of different threats and monitor those. Threat Mauler is a pay tool by myappsecurity.com. I believe it runs on Windows and Mac. I think maybe Linux, but it's another tool that lets you kind of model things and identify threats as well. So those are a few tools. So we're going to talk about the elevation of privilege game here for just a few minutes. When I was out at RSA a couple weeks ago, there is this game, Elevation of Privilege, and I've read about it, I've seen it. It's an interesting game, and in fact, the cool thing about it is that it's great for teams new to threat modeling. If you know nothing about what am I looking for, and generally some of your teams may not. You know, they say, well, how am I going to actually identify a spoofing threat, or how am I going to identify an elevation of privilege threat? I have no idea. So that may be completely new. Well, this is a game that was, like I said, developed by Adam Shostak, and it's based on a game that was created by a group at North Carolina called Protection Poker. And if you've been in the software world, and I have for many years, on the agile side, agile methodology, we used to do this thing called, what is it? I just lost it. The poker? I'm sorry? Planning poker. Thank you. Based on that. So you go around, okay, what is the level of effort on this, and how many points, and so on. Well, Protection Poker was based on threats and trying to identify the vulnerabilities and so forth. And so Adam then took that and extended it and say, well, hey, how can I apply Stride to that and come up with this card game? And so I got the cards a couple weeks ago, which is really cool. You can also go out to the site, a Microsoft site, and I have a reference here at the end where you can download a PDF file and cut them out for yourself. I don't know where you actually order this. I've been trying to find out where you order it, so I was glad to pick it up at a display. But I sent an email to Adam to ask him, where do you get these? So if anybody's interested, shoot me an email and I'll see if I can find out. But why a game? Well, everybody likes games. Well, it's most everybody. In fact, even here we have a Capture the Flag game today. It's fun, right? You're learning, you're trying something, you're finding things out. So as this game works, you draw a diagram of your system, and you draw cards, and basically you have, like the 2 of tampering, and the 3 of information disclosure. And what you're doing is, as you're drawing the cards, you figure out, does that card, you read it, does that card apply to my system somewhere? Okay? And then apply what makes sense. If it applies, you get a point, and then you count up the points at the end, and then take notes. Ultimately, you figure out from that what it is. You have a better idea of the threats in your system, and people are learning what threats are. So as I said, first of all, draw a diagram. Draw your system. I've got a browser, and I've got a web server, and I've got a database, and I do all kinds of other things with it, right? Very simple. And then, here's example diagram. And so the first card, 3 of tampering. Let's see, I cannot read it. Oh, here we go. An attacker can take advantage of your custom key exchange or integrity control, which you built instead of using standard crypto. Where does that apply? Well, it looks like it applies from the integrity host software to the integrity admin console. I see a couple of places here where that might apply. Next, Bob plays 10 of tampering. 10 of tampering, an attacker can alter information in a data store because it has weak ACLs or includes a group which is equivalent to everyone. Where does that apply? I guess I missed it. Let's see, 5 of tampering. Attacker can replay data without detection because your code doesn't provide timestamps or sequence numbers. Right there. Okay? And then Dan plays 8 of tampering. Attacker can manipulate data because there's no integrity protection for data on the network wire. Where does that apply? Right there. Okay? So what are we doing here? Well, we're just playing a game. I know nothing about this stuff, but I draw a card, and it tells me oh, it's tampering, and here's a little bit more about it. And then I look at the system and say, well, do we have that? No, I don't think so. I think we're good. Okay, put that away. Oh, here's one on denial of service and something about that. Oh, I think we have that potential. All right, put that down. We've identified something. Are we dealing with it? I don't think so. Okay, now we know. So it's a cool little tool. And a game, as I said, it's a serious game that you can use with your team to go through and help your team understand about threat modeling, help your team understand about threats, and then also understand a little bit more about, ultimately, how we're going to deal with those threats, which we'll talk about next. Addressing the threats. All right, first of all, and this is where I think, when I've talked to other threat modelers, unfortunately, something they miss. And I am a very big proponent of this. If you find there's a problem, file a bug. If you have noticed and you find that there is a threat in your system and it has not been mitigated, there is a way that someone could get in and do harm or damage or something, that's a bug. File it. Okay? Now, I'm a software guy. That's my background. And to me, that just makes sense. You file a bug. But again, I've asked a few other threat modelers, hey, do you do that? You help companies? No, that's what they do. I don't, whatever they want to do. Well, how do you close the loop? So, file bugs. Be sure to file bugs. All right? And of course, mitigation options. We have several. Leave it as is. Maybe it's too difficult, or maybe at the moment we don't want to handle it. It's on the next release, whatever. Remove it. Sometimes that feature has introduced a problem because of the feature. and we determine that the feature is not worth the security risk that we've introduced. And so we'll just remove it. Or remedy with the technology countermeasure. What I showed you earlier with Stride, I showed you on the left side all the problems. On the right side, I showed you the remedies. So for spoofing, authentication, for elevation of privilege, authorization, making sure your authorization is working correctly. Okay? And then ultimately, just warn the user. Let them know, hey, we have some problems here. If you log in as a user and leave your desktop or something, we're gonna let you continue to run for 5 minutes. Somebody may come along, so you may want to, things like that. Those are business decisions, and then the risks that you may introduce based on those decisions. So you may just warn the user, log out when you leave the browser. Don't just leave it sitting there. Stuff like that. Okay. So ultimately, when you're looking at these, and these are just simply how do I deal with the risk? Risk management. Do I leave it? Do I remove it? Do I take care of it, or I just basically pass it off to the user and say, it's your responsibility to do something because I'm still going to keep my feature that may be insecure somewhat and let you be the responsible person. That's essentially risk management. So the next thing you have to deal with is risk management. How do I know and when do I deal with fixing these things? Well, there are a few ways, and I just mentioned a couple of these. Bugbar comes from Microsoft, SDL, where they give, in particular with Stride, they give you critical, important, moderate, low. So they identify the different types of threats and the potential, okay, if I have this one in this situation, I may say it's a low. So then I have a determination, do I fix it now or do I fix it later, or is it something I may not fix at all? Critical, usually elevation of privilege are critical bugs, because as I said, if I'm a regular user and I can elevate myself to admin, game over. So that's usually a very critical one. Another way of dealing with the risk management is using the FAIR method, factor analysis of information risk. That in itself, and I saw a couple of weeks ago when I was at RSA, some people are saying, that's actually what we use the whole thing for threat modeling. And what that is actually approaching threats or issues from a business perspective as opposed to a software. And it was developed by Jack Jones in a banking situation where essentially everything could potentially be a risk, and with that risk, I could have some kind of harm or loss. You can imagine in a banking situation, the loss potentially of money or other kinds of reputation and so forth. So that's another method, but it's pretty big. So you may decide, well, I don't need something that big to figure this out, so I may use a bug bar. But if you want to have business involved and a lot of business processing, then that's also an option as well. I don't have it on here, but Dread, you may have heard that in the last 10 years. It used to be something that Microsoft threw out there for risk management. Dread is dead. As back in 2010, Microsoft officially dropped Dread, so no longer a part of the list of how do I determine the risk and deal with these things. Okay, validating. What did you do? Well, you have to just check and see, okay, here's my system, here are the threats, here's the mitigation, here's my plan. I think the number one way to figure this out is asking yourself, how do I know and when do I know that I'm done? The answer is actually two parts. One is, you're never done. But that's a hard sell to management, right? What's the budget for this? Unlimited. We'll never stop. Not easy to sell. But the reality is, at some point you do. And you don't always deal with all threats. For example, if it's a system that has never changed and it works and they've confirmed there are no issues, you don't need to keep threat modeling that system over and over and over again. Once you've validated everything is good and you're checking logs and it looks good, you don't need to keep going back over and threat modeling. So that's one way to answer the second answer for this is that when we've had some reasonable amount of assurance that we're in good shape, then we're done. But you still want to look at this for new features and new things that you need to add or changes to your system. Another thing about, and Showstack says this, how do you know you're done? Well, here's the thing. Do I have filed bugs? Have I a plan in place that's going to deal with this? And then also, I've got a good model. Showstack says, he quotes in his book, I don't know who said it, but all models are bad, but some are useful. Or wrong, rather. All models are wrong and some are useful. Your model is only as good as you try to build it, but just confirm. But having these in place is I think a good sign that you're heading in the right direction. So your challenge: add threat modeling to your toolkit. Okay, if you're a pen tester, you do code reviews, you do fuzz testing, or all other kinds of security work, I would encourage you to add threat modeling or look at it again, because especially on the front end for your work, threat modeling first. Secure design before new features. Before you do anything else, look at threats. Look at threat modeling first. And then there are many ways to do it, as I said, but just do it. Okay? So I hope, I can answer, or you can answer the question for yourself. Is threat modeling for me? I hope it is for you. It is for me. I hope it is for you. So finishing out, I've got a few resources here, but those will be available. You can look at online, and then the tools and so on. And we're at questions, and I'm leaving at least 9 minutes or so for questions. I went through that really quickly, and I apologize. The thing keeps flickering. Any questions this morning? Yes?
Hey, a question. How would you compare threat modeling with the more traditional risk assessments that have been done for years? Sure.
There's some similarities.
Yeah.
And in fact, I recently was listening to a podcast on risk management, and me knowing about threat modeling, and I'm listening to the words like risk, threat. It's almost like it's interchangeable.
Yeah.
And there's a lot of it that is. And certainly, as you saw it there at the end, you have to think about, okay, now that I know what they are, I still have to evaluate what the risk is. Because perhaps I found, we have a problem. Potentially, what's the likelihood of that ever happening? Very little, So I think there's some hand in hand. I think for me, though, for threat modeling in particular, especially from a software perspective, when you're saying risk management typically is when you're getting business involved, who may not know what's happening on the software side. And so that's where I think some distinction is. You know, they both have the same goal, ultimately, is what do we have here for our security posture? How can we improve it? But also we have a budget. We can't spend all the money on everything here. We have to figure out what makes sense, what's the most critical, and then deal with it accordingly. So that's my answer, that they're related, but not quite the same. Not quite the same. And by the way, when I was talking about, make sure you have developers involved in your threat modeling plan and your threat modeling team, because I don't know how many times that I've worked with a customer and an architect or a project manager says, yeah, this is the way we built it. It works like this and it works like that. And the developer pipes up and says, no, that's not how I coded it. Yeah. No, actually, we couldn't get that to work with low privilege users, so we just ran everything as SA and admin rights and root access because it just made it work better. And we just, when we deployed it, it didn't work when we tried to put it back on, so we just left it. Okay. You got to have your developers there and ask those questions because they actually know probably more than anybody else how the system actually works. Very, very key. Another question. Yes?
In the beginning, you said I should go around and collect documentation. Does that include getting oral histories from people?
Absolutely, yes.
Private knowledge is usually what carries companies.
Absolutely. So the question is, with documentation, should you get oral history? Yes. Because sometimes the group that you're working with, and as I said, ideally you want to do threat modeling on the front end before you develop the application, but that's not real world. Usually it's after the case, and sometimes it's many generations later. We've already had a team, and we had a team, and we had a team, and now there's a lot of turnover. It's a whole new team. They've inherited this, whatever it is, and maybe one or two have been there, and they know, they remember. You want them to be in those meetings, because they can tell you, oh, yeah, that was, Jim, he did that way back when, and he was a great coder, but he left, and yeah, you want the oral history, because that gives you an understanding of what was the intent originally. And, way back when, we didn't care as much about security. I mean, we did, but, security was, I have a firewall, right? I have something protecting me, and, inside, I trust everything. I trust everybody. You can't do that anymore. But we still have applications that's the way they were built. So, yeah, it's certainly good to have those in place, the people that know that history. Yes?
So in situations you said where, let's say, the lead engineer left, or the department might not be interested in participating with threat modeling, how would you handle those assumptions? Like, where you just have to make the assumptions, like, we don't really know this aspect of the product because this team's not willing to play ball.
Good, yes, good. In fact, Adam Shostak has a whole section on handling objections, and that's one of them. We don't have time, we don't have the resources. We've done it. It didn't work. We're not going to do it again. Those are, he has a lot of those. And in that particular case, I mean, what I would say is, in that case, is you need to at least get a few people that might be interested. And you may even ask the question a different way. I've done threat modeling with a group that said, we don't want to pay for threat modeling. Okay. But we want a code review. Or we want, I don't know, just review what we're doing. Okay. So I go in and I ask them, so what's your authentication? What's going on there? How are you doing your authorization? Do you have a bug tracking system? No. Let's set up a bug tracking system. Let's file them. And they have no idea that we've just did threat modeling. Okay? Now, I'm not saying get around things, but what I'm saying is understand that people have fears about things and work with them. But the objective is, okay, we're on the same team. We're trying to get the same objective. How can we get there that best utilizes the tools we have and the goals that we're trying to meet? So, but it's not easy. And again, I would say go look at Shostak's. He's got a nice list of how do you deal with those things. Yes.
Robert, do your clients often create a trust line between the auditing system and the admins?
A trust line between, the question is trust line between the auditors and the admin?
In your very high-level diagram, you had one trust line.
Oh, yes.
Audit and admins.
Right.
Do your clients often have something segregating the admins from the auditing system?
That's a good question. I'm not sure. I can't answer that. I've not seen that enough to say, yes, everybody does that segregation between auditors and admin. That's a diagram from Microsoft. But I can't really answer that from my own experience. Good question, though. Okay, yes?
When you were talking about Stride, you said it's a good way to identify threats, but it's a bad taxonomy. So what would be a good taxonomy for categorizing threats?
Well, what that means is about the taxonomy is that it's how can you categorize threats? I guess categorize, I think it's the word categorize. It's identifying, and I think some people, again, as I said at the very beginning, confuse threats with vulnerability. And that's where when someone says, I want to categorize, they want to have a vulnerability. So I've got an XSS threat. Well, that's not a threat. That's a vulnerability. XSS has potential of information disclosure. So I think that's how I would answer that in terms of categorize is that understanding the distinction between what it is that, here's the goal. It's not necessarily, XSS is a particular thing, but information disclosure represents, a much broader way of attacking your system that gives you more information or whatever by many, many ways. So I don't know if that answered the question directly, but that's how I see that. And again, that categorize, that comes really from Microsoft, how they don't want you to see it as, everything's this. It's not that. It's something that represents a threat that represents many different ways to do that thing through many ways, the vulnerabilities that are available. Okay? Yes?
So it's good to do the threat modeling on the front side and make sure that that's being addressed. Have you had any luck then moving that towards QA? I think a lot of the problems that we have in security is taking on way too much, right? So you do the threat model, and then you have to do the testing on the backside. And
Right.
there's a lot of releases that gets to be a large burden. So
Sure. Actually, the question is, how do you translate that to QA, threat modeling and testing and verifying and so forth? I think it's actually really nice hand in hand. I think that QA should also be involved in understanding. Even I didn't include them, and I apologize. I should have included QA. They should be there as well, because they're verifying this is tested and it works. I think also another aspect is the agile methodology. How does threat modeling work in that? Because sometimes threat modeling may be something you do, as a waterfall type thing. Not necessarily. It can go anywhere, really. I think that, in regards to testing, and again, Showstack has a lot of information about testing, is that they need to be involved as well, and they're also kind of helping you complete that loop. I'm not sure if that answered the question, but that's how I think QA needs to be involved in this as well, not just developers and all the other people that I mentioned. And I apologize. I'll throw that in the slide as well. Thank you. Did that answer or?
yeah, and you said that Showstack has some good.
He does. Yes. Okay, I think we're good. All right. Thank you, everybody.
Thank you.